Alright, here is a short video to explain how to draw Lewis structures of two ionic compounds, K2S potassium sulfide and AlCl3 aluminum trichloride. Let's start with K2S. So first of all, you need to understand what this subscript, the small number at the bottom, means. So the 2 here means there are 2 potassium atoms in one molecule of K2S. So there are 2 atoms of potassium and 1 atom of sulfur. So looking at the periodic table, we can say potassium belongs to group 1. It's on the far left. It's a metal. Metals have fewer valence electrons. That's also a metal. Sulfur belongs to group 6. It's on the far right. That's a non-metal. So a compound that is formed by a combination of a metal and non-metal is usually ionic. That's an ionic compound. So let's try to understand how an ionic bond is formed between 2 atoms of potassium and 1 atom of sulfur. So to do that, first thing I want you all to do is to draw or write the electronic configuration. Potassium has 19 electrons, looking at the periodic table. So 19 electrons can be arranged in different shells as the first shell will have 2 electrons, the second 8, the third shell will have 8 electrons as well, and the last shell will have 1 electron. The same thing here, that's 2, 8, 8, 1. And then sulfur has 16 valence electrons. You can get this information from the periodic table. That would be 2, 8, and 6, which means sulfur has 6 valence electron, potassium has 1. See, now the goal of any chemical bond is to let the atoms become stable by getting a full outer shell. So energy wise, the 2 potassium atoms would rather lose 1 electron to sulfur than gain 7 electrons. So let's show the valence electrons of all these atoms here. So potassium has 1 valence electron. I show that with a cross. This potassium also has 1 valence electron. I show that with a cross. And sulfur has 6 valence electrons. So 1, 2, 3, 4, 5, 6. So ultimately the goal is to become stable. So the potassium can become stable by giving away or losing that valence electron to this sulfur. And this potassium similarly gives away its lone valence electron to this sulfur as well. So that electron is gone, that electron is gone. As a result, now both potassium atoms get a full outer shell of 8 electrons. And sulfur gains 2 electrons from the 2 potassium atoms and also gets 8 electrons in its outermost shell. So since potassium lost an electron, it gets a positive charge. You must have seen this in my previous video, how atoms become ions, or how you could mathematically explain the charge on an ion. And this potassium also lost its valence electron. That gets a positive charge. Let's write that here. And sulfur gained 2 electrons from the 2 potassiums. So these are the original valence electrons of sulfur. It had originally 6 valence electron and it gained 2 from the 2 potassium atoms. So the cross represents the electron gained by sulfur from the 2 potassium atoms. Since sulfur has 2 extra electrons now, I'm underlining these. You don't have to underline this when you actually draw it. So the 2 crosses represent the 2 electrons gained from the 2 potassium atoms. So sulfur gets double negative charge, or 2 minus. And this is the convention. You write the number first and then the charge. But if it is just positive 1, you don't have to show the 1 here. So that is the Lewis structure of potassium sulfide. So the ions are oppositely charged. They have positive and negative charges. They are attracted to each other. That's how the ionic compound K2S is formed. Let's take a look at a different type of ionic compound. Let's say aluminum trichloride. Aluminum trichloride has one aluminum atom per molecule, and the subscript 3 means there are 3 chlorines, Cl, Cl, and Cl. And aluminum is a metal. This is chlorine is a non-metal, so that's again ionic. So let's do the same thing just like we did on the left hand side. Let's write the electronic configuration of aluminum. It has 13 electrons. You can get this information from the periodic table. So 13 electrons can be distributed in 3 different shells as 2, 8, and 3. Chlorine has 17 electrons, so that would be 2, 8, 7. Similarly, this chlorine has 17, that would be 2, 8, 7. And this chlorine will also have 2, 8, 7. So again, the goal is metals have fewer valence electrons, so they tend to lose electrons. So aluminum has 3 valence electrons, so for this aluminum atom to become stable, it can lose 3 of its valence electrons to the 3 chlorines. So let's show the valence electrons of aluminum here. That's 1 valence electron, that's the second. There are 3 valence electrons in aluminum, whereas on chlorine there are 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Similarly, this chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And the third chlorine also has 7 valence electrons. 4, 5, 6, 7. So these are the valence electrons of aluminum and chlorine. So as I said just a few seconds ago, for aluminum to get a full outer shell of 8 electrons, it has to lose its 3 valence electrons to the 3 chlorines. So it will give away one of its valence electron to one chlorine atom this way, and it will give the second valence electron to the second chlorine. It will give away the third valence electron to the third chlorine. So as a result, aluminum lost 3 valence electrons. So the charge on aluminum now would be Al3+. And each chlorine is gaining an electron from aluminum. So these are the original valence electrons of chlorine, and the cross represents the extra electron that is gained by the chlorine from aluminum, so it gets a negative charge. It has 1 electron more. So similarly, the second chlorine atom gains an electron from an aluminum. So the second chlorine atom also originally had 7 valence electrons, and it gained 1. This cross represents the extra electron that is gained from aluminum, so this also gets a negative charge. So we have the third chlorine. We can draw these chloride ions around the aluminum. So originally this chlorine also had 7 valence electron, and it gained 1. The cross represents the electron gained from aluminum. So if you're wondering how to draw these structures, usually the atom with fewer protons can be shown in the center. For example, aluminum has 13 protons, chlorine has 17 protons. So since aluminum has fewer protons than chlorine, I can show this in the center and draw the chloride ions around it. Now as a result, since aluminum lost 3 valence electrons, now aluminum has an electronic configuration of 2 and 8, whereas a chloride ion, as a result, it gained 1, so it has now 2, 8, 8. This chloride ion also has 8 electrons in the valence shell, and the third chloride ion also has 8 electrons in the valence shell. Let me show that here. So the point that I'm trying to make here is, by forming an ionic bond, both aluminum and chlorine, or chloride ions, they got a full outer shell. So since aluminum is a metal, chlorine is a non-metal, so the bond that is formed between them is called an ionic bond. that completes the video on the Lewis structures of ionic compounds.